Submarine hulls would crumble. Human bodies would be crushed instantly. Yet fish swim here comfortably, their soft bodies adapted to the pressure, their internal fluids matching the pressure outside so perfectly that they feel nothing unusual. Food is scarce here. The phytoplankton that feed the surface ocean cannot survive without light. No plants grow in the midnight zone. The only food source from above is marine snow, the constant gentle rain of dead organisms and fecal matter drifting down from the upper ocean. Flakes of organic material spiral slowly through the darkness, and creatures in the midnight zone wait for them, mouths open, filtering the water. But marine snow is not abundant. Less than 5% of the food produced at the surface makes it down to the deep sea. Most is consumed by animals in the twilight zone or breaks down before it reaches these depths. So the creatures here have adapted to scarcity. Their metabolisms run slow. They move little. They wait. Many have enormous mouths and expandable stomachs, allowing them to consume prey larger than themselves when the opportunity arises. The gulper eel is perhaps the most extreme example. Its body is mostly mouth, a huge gaping jaw attached to a thin ribbon-like body. Its stomach can stretch to accommodate prey much larger than the eel itself. When food is rare, you don't waste opportunities. The viperfish is another midnight hunter, terrifying to look at with its needle-like teeth protruding from its jaw. The teeth are so long that the fish cannot close its mouth completely. Some of the teeth curve back over the fish's eyes. It hovers motionless in the darkness, waiting, and when prey approaches, it strikes with incredible speed. The teeth impale the victim, holding it while the viperfish swallows. But perhaps the most famous midnight zone resident is the anglerfish. These fish have developed a hunting strategy so effective that it seems almost unfair. Female anglerfish, which are much larger than males, have a modified spine that extends from their forehead like a fishing rod. At the end of this rod dangles a fleshy lure called an esca. And inside the esca live bacteria. Not just any bacteria, but bioluminescent bacteria that glow with a soft blue-green light. The bacteria and the anglerfish share a symbiotic relationship. The bacteria have a home inside the lure, protected and supplied with nutrients by the fish. In return, they produce light. The anglerfish waves its lure through the darkness, and prey fish see the light. They approach, curious or hungry, thinking they've found food or a potential mate. Instead, they find jaws. The anglerfish has a mouthful of sharp, inward-pointing teeth and a stomach that can expand to hold prey twice its size. It's an ambush predator, perfectly adapted to a world where opportunities are rare and must be seized immediately. Scientists have discovered that anglerfish don't inherit their bioluminescent bacteria from their parents. The bacteria live freely in the water column, and young anglerfish must acquire them from the environment. As female larvae mature and develop their lure, bacteria colonize it, moving in from the surrounding seawater. Different species of anglerfish host different species of bacteria, and the bacteria have evolved specifically for this symbiosis. Their genomes have shrunk over time, losing genes they no longer need, keeping only the essential ones. They've given up independence to specialize in producing light for their host. The male anglerfish has perhaps the strangest fate in the animal kingdom. Males are much smaller than females, sometimes 10 times smaller, and they don't have lures. They cannot produce light. In the vast darkness of the midnight zone, finding a mate is nearly impossible. So when a male encounters a female, he doesn't let her go. He bites onto her body and holds on. His tissues fuse with hers. His bloodstream connects to hers. Over time, his body atrophies. He loses his eyes, his fins, his internal organs. He becomes a parasite or perhaps more accurately, an external reproductive organ. When the female is ready to spawn, he releases sperm to fertilize her eggs. Some females have been found with multiple males attached to their bodies, permanent partners fused in the darkness. Life in the midnight zone is strange, slow, and alien. But deeper still, conditions become even more extreme. Deeper still lies the abyss. The abyss opelagic zone extends from 4,000 meters down to 6,000 meters, reaching in many places to the seafloor itself. This is the abyss, a word derived from the Greek for bottomless. It's not truly bottomless, of course, but to the ancient sailors who named it, it might as well have been. The abyss covers 83% of the ocean floor, a vast flat plain stretching for thousands of miles in every direction, broken occasionally by seamounts and ridges. The pressure here reaches up to 600 times that at sea level. The temperature remains a constant 2 to 3 degrees Celsius. And life becomes sparse. The abyssal plain is often called a desert, and the comparison is apt. Food is scarce, energy is limited. Survival requires efficiency and patience. The tripod fish is perfectly adapted to this environment. It has 3 elongated fins, 2 pelvic and 1 caudal, that it can stiffen into stilts by pumping fluid into them. The fish stands on these fins, sometimes a few feet above the seafloor, facing into the current with its mouth open. It waits for copepods and other small crustaceans to drift by. Its eyes are tiny and nearly useless in the darkness. Instead, it relies on sensory organs that detect vibrations in the water. When something edible approaches, the fish sucks it in. The tripod fish is a hermaphrodite, possessing both male and female reproductive organs. This adaptation makes sense in the abyss, where finding a mate can be impossible. If you encounter another member of your species, both of you can reproduce, regardless of sex. Sea cucumbers roam the abyssal plain in surprising numbers. These soft-bodied relatives of sea stars and sea urchins crawl across the sediment, using tube feet to move and feeding tentacles to gather marine snow. Some species are enormous, reaching lengths of 2 feet or more. They're often brightly colored despite the darkness, yellows and oranges and reds, perhaps as a warning to predators. Some sea cucumbers contain toxic chemicals in their skin, deterring fish and other creatures that might try to eat them. One particular sea cucumber, nicknamed the gummy squirrel, has a long tail that arcs above its body like a sail. Scientists speculate that it uses this tail to catch weak, deep sea currents, allowing it to drift across the seafloor in search of better feeding grounds. It moves slowly, deliberately, sifting through the sediment with 18 feeding tentacles arranged around its mouth. Each particle is examined, and anything containing nutrition is consumed. Rat-tail fish, also called grenadiers, are among the most common fish in the abyssal zone. They have large heads and long, tapering bodies that give them their name. Their mouths face downward, adapted for feeding on the seafloor. Some species produce sounds for communication, drumming their swim bladders to create clicks and buzzes that travel through the water. In the silence of the abyss, sound is a valuable tool. The dumbo octopus lives here too, hovering above the seafloor using fins on its head that resemble elephant ears. It's one of the deepest dwelling octopuses known, found at depths exceeding 7,000 meters. To survive the crushing pressure, it has lost its ink sac. Ink is a defense mechanism that works in shallow water where light and visibility exist. But in the darkness of the abyss, ink serves no purpose. The dumbo octopus has adapted accordingly. Most abyssal creatures have slow metabolisms and long lifespans. Growth is slow. Reproduction is infrequent. Everything is conserved. Energy is precious.